Do you make awesome strip board modules for your DIY synthesizer projects but are bummed about how hard and expensive it is to make great looking front panels for your sonic artwork? In this video, I'll show you how to take your front panels from looking like this to this, and it will only cost you a couple of bucks a panel. I'm Brian from EurorackDIY, and I'm here to share with you how I make inexpensive Eurorack modules that sound and look great. This is part 2 of a series showing the steps I take to make Eurorack modules. In this case, a passive multiple. While it's a simple module that doesn't do a lot, I'm using it to demonstrate how to make great looking front panels. In this video, I go through the details of using KiCad to lay out the front panel and get all the dimensions correct, mounting holes in the right places, etc. I also show a little bit about how to create graphics and labeling for your front panel. If you haven't already, you might want to go back and watch the first video in the series to learn more about exactly how this fits into the overall process. Let's get into it. Okay, so with all that, I'm finally ready to dive into CAD and start laying out my faceplate. I use KiCad. It's a open source schematic capture and PC board layout software. We'll go ahead and use that today to demonstrate. There are other tools out there that you can use that might be more friendly or easier to do things with. KiCad's a little bit fiddly with how you lay things out and stuff. It's not exactly, I don't know, the best of 2D or 3D CAD software for dimensioning things and stuff, but there are ways you can work around it, and it is getting better and stuff. So I'll assume you already have KiCad downloaded. I'll leave a link below to where you can get it and install it for yourself, and all the instructions are there. I'm gonna do lay out two boards here in KiCad, and so we're gonna do the one for the faceplate, and then also I'm going to put the actual connectors themselves on a printed, on a PCB, actual manufactured PCB, and solder them onto that. So we'll look at that too. It'll be very simple electronics and stuff on that, just connecting the various parts of the connectors together. So want to try to put them both into the same project. So we're going to go ahead and start a new project and give it a name. I name all my modules after Southern California beaches. This is a narrow module. If I'm going to put the name on it, it needs to be a short name. So Point Doom is one of the smaller, it's one of the smaller beaches and one of the smaller names that I can fit on there. So from there, I've got my project now. You can kind of see all the files and stuff on the left-hand side here. The ones in the green and green and gold with the green and gold icon, that's the actual PC layout itself. And then the schematic is kind of, it looks like a electronic circuit schematic and named .sch. So I'm going to go ahead and open up Point Doom, the top level schematic, and over here on the right we can create hierarchical sheets on the schematic. With that, you'll notice whenever you get into like a pencil shaped thing that you're going to be in a place or a drawing kind of mode. And so just click once, we get a box, and then we get that, and we'll also be asked for a file name and a sheet name. So for the front panel, we'll just call it panel, and we'll also give the sheet name the same thing. This is just sort of to give it a file and a place to be. And then we'll also create another one for the board. And name the file and the sheet after the board. Go ahead and save from here. You can also do Control-S to save things. And then we'll switch back to, so this is the schematic editing tool. Whenever you see schema up here, this is how we edit schematics. We'll switch back to the KiCad, the top level of the project file itself. And as you can see now, we have a board.sch and a panel.sch here. So moving on then to laying out the front panel itself. We'll go ahead and open panel.sch, which will bring it up in its own schematic editor. This is kind of one of the things that's a little bit weird and fiddly about it, because we want it to be here to be able to open up run PCB new to actually start the board layout tool from this place, and it says it's already running. So from here, you're going to want to learn some sort of navigational tips or navigational sorts of things. I tend to use the scroll wheel on my mouse to scroll in and out, so it scrolls in or out at where the center is placed. I just start setting things up from this corner up here, so I'll put it up here and go ahead and zoom in a fair amount. Because everything, if you remember, you know, as we set out, right, these things are 9.8, 128.5 millimeters big, so they're tenths of millimeters, are some of the dimensions and stuff. So we're going to go ahead and use a grid that's also in tenths of millimeters. And then also looking on the screen, you can see where your mouse's location is by looking down below. There's the X and Y. And then dx and dy are offsets from wherever you put a marker. So just for the sake of getting this one going, so the first thing is we're going to go ahead and set our grid origin up to be at, like, say 15 by 15, just a known place. Doesn't matter a whole lot for this, but other kinds of things you might do, you might want to have, you know, sort of where you're starting and stuff, because you might have to do some calculations and stuff. So go ahead, and I'm just watching the X and Y to get it 15 by 15, and I just place it there. I'm also going to want to set my offset from this point here. So if you hit the space bar on your keyboard, you also notice that doing so, now the dx and the dy go to 0.0, 0.0. So we've established an origin. This mark will stay here so we can see it. Talked a little bit earlier about the layers of the PC board, and on the right here it has all the drawing layers. If it's F, it means front. C is copper, so the front copper, front and back copper, the ones we'll care about, right? The front and back copper, the front and back silk screens, the front and back masks. Also, I use drawings a fair amount. They don't get printed on the board or anything, but they're used I use them for layout here. And then most importantly, edge cuts, which I'm going to go ahead and select now, is where in the manufacturing process they actually cut the board or route out things like holes, which we'll have mounting holes, and then the mounting holes for the screws to screw it into the rack, and then also mounting holes for the jacks themselves. So basically, whatever layer you have selected, the drawing tool that you use will draw with that layer if it's appropriate. So in this case, we're going to add graphic lines as the edge cuts. So we're going to take and make the outline of the board first, and we're going to do that by basically drawing 4 lines for the outline of the board. Go ahead and zoom in on this here so we can hit the point exactly, so we know where it is. Now, single click once starts the drawing tool, and as you can see on the bottom left, we have more information about the segment that we're drawing. So it gives the length, and it gives an angle off from 0 going across. So we want to constrain this angle to 0.0, and so to do that, you'll hit the control key. If you hit the control key, as you can see now, it'll just go in 45. So this way we can drag it back and forth till we make it the length that we want. Go ahead and zoom out here so we can get all the way out to the length of around 9.8. And as I mentioned, right, 9.8 is the width across, so that's what we're shooting for here. Hold down the control and find 9.8, and then we'll click again. And if you click once like that, just one time like that really fast, you'll continue drawing. So now we're going to go down the 128.5, zoom out again so we can get close to where we need to be. If you look, then the length is close to the 128.5 here. I'll go ahead and hit the control again so that to constrain the angle. Zoom in a little bit. and look for that 128.5. Make a single click again and start with the next segment, Control, and then this one we're going to go back 9.8 millimeters. And then this last one's a little easier because we're going to go back up here to where we started, land on the original space, get it right back on the original space, and then double click real fast twice, and I wasn't fast enough. So from here, if it hasn't closed out the drawing, I can just hit Escape. It stops that. I'm going to hit Escape one more time to get out of the drawing mode, and as you notice, we go back up to the error mode here to be able to select. So we now have the outline of the board. One of the things you can do is you can put dimensions on your drawing. So we could add a dimension, and we'll put 1 point there. But the other one, you see it gets a target when it's like lined up on a vertex or the end of a segment or whatever. And as you can notice, we've got our 9.8 millimeters here. And then we can also do the same for the vertical. Zoom out again, put the mouse where you put your cursor where you want it, and then again find the point, drag this out a little bit, and then we can go back up and look and see that we're also 128.5 millimeters. Now these are done on the drawings user, the user drawings layer, these dimensions and stuff. And one of the things you can do is if you want to unclutter your drawing and get things out of the way so that you can see, you know, just what's important or whatever, you can click on the checkbox and then deselect it, and now you can see just the edge cuts. So we're also going to make use of this the user drawings to be able to make ourselves some guidelines to be able to find the center of the board, yeah, basically the center of the board, the center of the top, and then the center of the board. So again, we can come up here to our origin point that we've set, click and start drawing a line. Now, as you can see, the line is white because we're doing this as a user drawing. Again, Control to constrain ourselves, and then as we calculate it out, right, it's 4.9 millimeters is what we're looking for the length here. And we got that. So, and we're going to go ahead and let it go because what we want to do is find the absolute center of the board. So we want to go ahead and trace down 64.25. Now, if you remember, we set the grid to 0.1 millimeters. So we actually won't be able to get to exactly 64.25. So I'm going to show you another trick to dimension things. Maybe when things aren't, exactly, where they're going to exactly line up, or if you make a mistake and you make a line segment and it's the wrong width, the wrong length or whatever. Again, Control to constrain it. We're fairly close at about 60.3 millimeters. I'll try double clicking again, and that time I got it. So end the line segment there, but of course it's the wrong size. Again, we can go Escape, or we can click right on the arrow there to get back to the selection mode. Now, what we can do is we can go in and double click on the line itself, and you'll get the line segment properties. And because we started at 15, 0.1, we start at 15 millimeters by 15 millimeters off. This is where some of that math kind of comes into play. So we know that we started at 15 millimeters off. We're going to add the 64.25 to it. So we know that would actually add up to 79.25. And so, the endpoint for the X needs to be 79, or for Y needs to be 79.25. That 15 plus 64.25 millimeters from the origin point, the upper left-hand corner origin point of the drawing. And that's where we want to end that. Now again, if we want, it's often a good idea to check these things. So we can go back, select the dimensioning tool, and find our corner point when we get the target like that. and find the end point here, again with the target, and then drag it out. And we can see, in fact, we got the 64.25. Escape again to get out of that mode. Okay, at this point, we now know where the center is. Because everything's off, now it's off this, the center is off the grid by, half or 0.05 millimeters. We're going to want to reset things to be back there. So we'll go ahead and again select, set the origin point for the grid. We'll find this endpoint here. Again, we'll wait till we get the target so we know we're exactly on the point. And we'll click it, and now we've reset the grid target to there. So everything will be, now the grid is relative to that. So everything we place from this point will be from the exact center of the board. And then also hover over that same spot and hit the space bar again, just so that we can have our dx/dy coordinates there. In case you're watching those, it's always a good idea to kind of keep track of that too. Now what we want to do is draw the holes for the jacks. And to do that, again, we're going to want to figure out where we want to place it, and relative to this starting point. We're going to go back into the drawing mode again for the user, and then at this point we're going to use the information over here. So we're exactly at the center. We said we want the two to be 16 millimeters apart. So in fact, we're going to go 8 millimeters up here to put the center point for this very first jack. And then we're going to use a nifty little feature of it to replicate them to get the others after we've drawn the circle. Oh, and another thing too I realized is I forgot to mark down on here when we were making the cheat sheet with all the dimensions and stuff, the actual diameter of the hole that we're going to need for the jack. And I don't know if you can see this or not, but they're basically 6 millimeters wide, just like the holes for for mounting it in your rack are dimensioned. They usually take 3 millimeter screws, but there's tolerance of 3.2. So if that's 6 millimeters for the jack, we'll say that we want a diameter of 6.2, which is a radius of 3.1. And those are both in millimeters. So okay, we want to go 8 millimeters up from the center line, and then make ourselves a hole there like that. So again, we're going to use we're going to go ahead and use the drawings, the drawings user layer. We'll start here. Oops. Get it on the center point. Click once, click and let go, and then come up to just again watching in the lower left-hand corner for the length to 8 millimeters. Now I'm going to click just one time here, not in the segment. I'm going to drag it out here to the side and double click again, and that's just mostly so that for visual reference, so that I can see that I've put the line there to do that. Now we want to go back to edge cuts because we're going to want to cut or route a hole for it. In this case, we're going to use a circle. So right, because it's a round jack, and so we want to go ahead and use the circle for that. Zoom in so that we can hit the exact center point of where we drew our reference line. Click once again to start the circle, and then you pull it out to get the diameter of the circle. And we said that, again, that the radius on this we want 3.1 millimeters. So I guess we'll zoom out one more time so that we can get to, again, watching the radius there. You're going to want to keep your cursor on that same line as where the that same horizontal line as the other one, because otherwise you'll get like funky in between points and stuff for your radius, because it's on an angle. The control constraint thing doesn't work on this one, so you just need to make sure that you're seeing nice round numbers, 3.100 millimeters for the radius. And once you're there, just single click again, and you have your hole placed. If you want to check, sort of the work and see how it's going, you can unselect the user drawings and see and kind of unclutter things and see what you have there. Okay, we'll go ahead and put those guides back on. Get out of drawing mode again. We want to replicate this circle. So you can, if you not double click, but if you single click on it to select it, and you'll notice it gets like slightly lighter yellow, and then right click, what you'll find is create array. So we're going to create an array of these. These are evenly spaced, 14 millimeters apart in the upwards direction. We can't go down because we can't create the array downwards because it would because this gap here is different than the others. So what we're going to do now that we have this tool is like we only want one of these horizontally, and vertically we want a total of 4. And then this is where we get to put in the spacing. Horizontal spacing doesn't matter because we're not going to have multiple, but the vertical spacing, this is where we go ahead and put our 14 millimeters that we said we wanted. The vertical spacing itself is going to be minus 14 millimeters. As we said, it's going to be 14, but we want to go up, so that's in the negative direction. And then things like the horizontal offset, vertical offset, and all that stuff don't matter. Staggering doesn't matter. Numbering doesn't matter to us. So we can go ahead and click OK. And if we zoom out, we'll see that we have the 4 holes exactly spaced that way in that direction. Now, we're going to go do the bottom holes essentially the same way. We'll go ahead and draw ourselves another guide. Starting here. Go down 8 millimeters. And out with a little tick mark. Now we can once again go ahead, select the circle drawing tool and edge cuts again because we want to draw this as an edge cut. Get ourselves placed exactly in the center here. And then move out until we are at a radius of 3.1 millimeters. Again, looking at the information in the bottom left of the screen. Click once and we have our circle. Hit escape to get out of the circle drawing mode. Now we're back in selection mode. Select the circle, create array, and it's going to be the same information. It's just that this time the vertical spacing is going to be 14 because we're going downwards. So we can click OK, and we have our holes placed down. Turn off the user drawings to be able to see this. Okay, one last thing we have to do is put in the holes, the mounting holes here and here. And so what I said is they're going to be 7.5 millimeters from the left edge, and then 3 millimeters up, and a radius of 1.6 millimeters. And we're going to use our same trick to draw guidelines and stuff. I probably should have done these before the other holes, but we need to get ourselves back onto the edge, the grid for the edge, and so we're going to go ahead and place the grid origin back here, and we'll hit space to place the other virtual origin from there too. Okay, so again we can draw. We're going to go ahead and draw ourselves a guideline. Actually, make sure that so we get back in the line drawing tool. Make sure that we're in the user drawings again. Zoom in on this, and what we want is a guide that's, oops, let's zoom out a little bit, that's 7.5 millimeters over. So again, looking at the bottom left of the screen, we can see that we're 7.5. I'm holding the control key down to make sure that it lines up horizontally, and then click once. In this case, we can just continue on from here. Again, hold control down so that we can strain it. As we said, we want to go 3 millimeters down for that. And then I guess escape to go ahead and get out of the line drawing mode. And we'll go ahead and do exactly the same thing on the bottom corner. Using the scroll wheel again to scroll in and out. Holding it scrolls in and out based on where my cursor is on the screen. So you can put my cursor where I want it and scroll in. Okay, so we're here in this corner. Again, we'll click to start our line. Scroll out a little bit. Control key down, length 7.5, up 3, holding the control key down again, double click to stop my line there, and now I have the guide there. Again, these are going to be routed holes. I don't think you can actually get them drilled that big. The drills aren't that big, so it's okay. The routing them works just perfectly. So we're going to change to edge cuts, back to the circle drawing tool. Go ahead and zoom in so we can make sure we're centered exactly on the point. Click and start our circle and keep ourselves on the same plane so that the radius goes up in nice even increments, and we're shooting for a radius of 1.6 millimeters, which is, click over from there, which is right there. Zoom out, zoom in, and go put the one up on the top also. Okay, with that, again, we'll go ahead and turn the drawings off. Let's take a look at what we have here. And it all looks pretty good. That's exactly what we want. We could actually stop right here and start saving the files for the manufacturing files and stuff and outputting those and send this in for manufacturing, get a perfectly dimensioned PC board that would work perfectly well as a front panel. However, right, we still have the opportunity to put some graphics on it. We get to put the gold colors on, the white colors on. And so up next, I'll show you a little bit about how we prepare the graphics to go on, and then how we put them on the board. So to put the graphics on the panel that we want to have there, we're going to use a couple of the other layers, as I talked about earlier. We're going to be using, we're going to be adding things to the front mask layer and also to the front silk screen layer. What we have to do first is we have to, well, in PCB layout tools, what you're typically doing is you're placing footprints and connecting those together with traces. And so we have to have a way to create footprints that represent the graphics, put them onto these layers, the front silk and the front mask layers, and bring them into KiCad so that it knows about these graphics and the way they are. And so the way that I do this is I use Inkscape. Leave a link below as to where you can go to download it and install it yourself. It too is a open source free software that does vector graphics and lays things out that way. There's also an extension for it called Shenzhen, which is able to convert the graphics in Inkscape to the appropriate file types for creating footprints in KiCad, and I'll show you how to do that too. So the first thing we're going to want to do is start Inkscape, and I've prepared the graphics elsewhere. I'm not really great with Inkscape. It would probably be a good idea to go in and learn Inkscape yourself to do these kinds of things. I'm going to open up the files that I want to use. I want to make sure that the files already have a name, and so first of all, I'm going to work on the logo or the graphical name that I've given to the board. So I'll put a name on it. It's called Point Doom. Select everything on the board and show you that it's there. So to select everything, I do Control A and then hit the 3 character to be able to zoom the viewing window to the size of the graphic. At this point, we want to do a couple things. First of all, we want to go ahead and prepare this particular drawing for the Shenzhen SVG to Shenzhen tool. And so we click on prepare. Well, actually, before we do that, I'll just show you here that for the layers, there's no layers defined at all here. And what we're going to do is we're going to create a layer that represents the in this particular case, the front mask for the front solder mask, and put this Point Doom graphic on top of it or onto that layer. So we're going to run the prepare document, which will create the proper layers to use. In this case, we said we want it to use front mask. You can actually put all of these in one, and you could create a footprint that had all these different layers on it, and put various things into that footprint for each of the layers all at once. I'm just going to prepare mine separately. Roughly a document of about 15 millimeters by 15 millimeters, just so that it's able to contain it. We click apply, and it brings up a graphic. It's too fast to see what it says, but we should know that it's there. And then you have to kind of go looking for where you're there. If we hit Control A and then a 4, it will go ahead and basically everything is selected. This little corner over here represents where the drawing itself is on the board, and so we want to draw our graphic on it. But the other thing we can see is that the graphic, as I brought it in, is way too big to fit onto the PC board. We know that the board itself is 9.8 millimeters wide. In this case, I happen to know that I want this to be 9 millimeters. So what I'm going to do is while I have this selected, the point doom selected, I'm going to lock it, lock the height and width so that they move together proportionally. And I know that I want the width to be 9 millimeters. And actually, I need just a little bit more screen here to get the units. I want to make sure that the units are millimeters here. And so I'll go ahead and say 9 millimeters. Now we'll go ahead and scale the height and width both appropriately. And then also, while we have this selected, the point doom thing, we're going to go to layer, and we're going to say move selection to layer, and then that will give us a choice of layers that we want to move it to. In this case, we want to move it to front mask, so we keep that there. We'll click move to have it move to the front mask. And now if we drag this up into the window, we'll hit the 4 on the keyboard again to zoom into just that portion. And we can see from here that if you use the visible things, if you hide the front mask, you hide the text, the point doom text, and that's how we know that we've got it the way that we want it. So that's basically where we want things at this point. Now what we have to do is we have to save it. We go back to the extension. We want to export it as a footprint to KiCad. So back to the Shenzhen extension, under extensions, we'll do export to KiCad. And then in this case, we want to make sure that we have a folder to put it in. I like to put them all in a subfolder of where we have the KiCad project itself. So I'm going to create a new folder here under point doom, and I'm going to call it graphics so that we'll know where to find it later. We select that, that's the folder. We'll put it in. It will put it into that folder with the same point doom name, and then an extension that KiCad understands. Click apply. Again, a dialog comes up. It's difficult to read. It's a little bit about the nature of this Shenzhen tool. It's a little bit clunky, but it also does a really good job of building the KiCad footprints. So that's it for the point doom. I also have a graphic for the input ports that I'm gonna put above the input ports that says in. So we can go ahead and open that up also in Inkscape. And it's much the same deal. We can Control A to select everything on the page. Type the number 4 on our keyboard to select it. Go back to extensions. Prepare this document for it. In this case, I want this text to be in white. So we're going to switch from front mask to the front silk screen for this particular one. That will make it the white part. Apply to get the document for that. It's moved some things around as it does it. So again, I'll type 4 on the keyboard and we'll just go ahead and find everything. We still have the word in selected. In this case, it's still not the right size. I want to, again, lock it. In this particular case, I want these characters to be 1.68 millimeters high. This is just from trial and error. So I'm going to go ahead and hit 1.68 and it will shrink it down to the size that I want. again, go to Layer, move what's selected, the word in, to the layer. We want to move it to the front silkscreen layer. Put it into our graphics place. Again, we can check to make sure it's there by turning off, that it's on the right layer, turning off and on that layer, the visibility of that layer. And once more, go ahead and export to KiCad. For some reason, it doesn't keep the graphics file selected. We'll go ahead and reselect it, or the directory, the graphics directory, and apply. And we'll get in. One more thing that I did is for the output ports, I've drawn a graphic that goes around the 3 output ports in each group and then labels them out at the top. And for that, we'll again go ahead and open. Let's see, I'm going to close that. Go ahead and open out.svg. Control A and the 4 again to select just it. Expand our screen out so we have a little bit to work with. I want to go ahead and convert it to millimeters. And actually, let's go ahead and prepare the document first. This one's still going to be on the front silk screen. It's obviously a little bit bigger, so we'll go ahead and give it a little bit more room on the height. 45 millimeters should be enough. It's prepared the document. We'll hit close that dialog, hit 4 again to get it. Now it's gone ahead and scaled the drawing to a different size. Now, one of the things that we're going to see here when we do this, so I happen to know for this one too, the width is 9.375 millimeters is what I'm looking for, so that it mostly fills up the width of the screen. When I do shrink it, you'll notice that the outline for it has changed. And so one of the things that we want to pay attention to on these are the fill and stroke styles, and you'll see on the next graphics we prepare too that it becomes even more important. And in this particular case, I want the width of those lines to be 0.35 millimeters. So we can go ahead with everything selected, change it to 0.35. One other thing you'll notice on this graphic is that there's a plus sign in the middle, and I'm going to use that as I build the footprint and as I put the footprint on the board to align it with the center of one of these holes. It's just something I put in it as I was laying out this circle and making it. Okay, so with that we have, basically we have the right width that we want for this, and we have the drawing done. Also, don't forget to move the selection to the front silk screen layer. I know it doesn't look like anything happens when you do that, but it turns out that that's necessary. It's on the default layer or something until you do that. Go ahead and move it up to the place where we want it. We can go back to Layers View. Again, just checking. Turn off visibility. Sure enough, it goes off. And one more time, export that to KiCad. Back to the annoying step of selecting the graphics file, just so to make sure that everything's in the right place, and do apply. And close. And then there's one last thing, is again, Southern California beaches, palm trees, whatever. So I've got some line art that I like to use for palm tree that I put on some of my other boards and stuff. And it's I'll open it up here and take a look at it. Really quick. So the palm tree. So it's a fairly large piece compared to these others, which are all pretty small. So it needs a little bit of special handling, and then also because it's line art, the line thicknesses and stuff will change. So again, we're going to select the whole thing with the Control A. As you can notice, each of the little line segments is like its own separate selection in this, and it's like huge, right? It's well, let's change this to millimeters. It's 133 millimeters by 262. In this particular case, I want this to be 7 millimeters high to fit just a couple little spots on the board where we have room to put that. So before we do that though, before we resize it, let's prepare our document. In this case, I'm going back to the front mask. I want these to be a nice gold looking trees, so they're nice and pretty that way. A little bit of difference between the white that we've been doing on some of the other, on the words. So the text is in white. The graphics and title of the board and stuff is in gold. Takes a little bit longer to prepare this document. I think it's because there's so much stuff on it already or something, the way the script works. It makes it even bigger, I think, for the tree. Close, and we'll go 4. As you can see, the document itself is up here. That's basically, actually it's not exactly the size. It'll be fine. It's not exactly the size I wanted. I left it the same size, the same height as the previous one. This tree will get a little bit lost in it, but that's okay. So go back and do the same thing. As I said on this one, I want it to be 7 millimeters high. So it's going to shrink it down like, oops, I forgot to lock it. Fortunately, Control Z undoes what you do. Lock the two together. Now do 7 millimeters high, and we get a much smaller graphic out of it. Type 4 on the keyboard again, it will select the whole thing. And it's also important to pay attention to, as you can see, there's almost no strokes or lines in it at this point. It also scales the strokes down by pixels, and actually I guess they're a little bit bigger, a little fatter than we would want. The JLC PCBs, their particular processes and stuff, they can go down to line widths or resolution, if you will, on the stuff that they print. And I've submitted boards in the past that had line widths that were way too skinny and too narrow, as I'd done like these shrinking tricks and stuff, and they came back and they had to modify them and stuff. And so to save ourselves time on that, it's important to pay attention to these. I believe that their minimum silkscreen width, which also applies to seems to apply to the solder mask, or works well with the solder mask, is 0.153 millimeters is what it states. I'm just going to go with 0.16 millimeters in this case, because that's what it wants. And before I unselect it, we're going to go ahead and move it onto the proper layer, the front mask layer. We'll move it there, and that's what sort of created the visibility. And just basically move it to the center of our drawing here. I'm going to click outside just so we can take a real quick look. So it's rather filled in. It's going to be really small. You're not going to get quite the resolution because it's very small, but it needs to have thick enough lines so it'll show up at all inside the printing and stuff. So with that, we're all ready to export it to the place, to KiCad, or to the KiCad format, footprint format that we want. Select the graphics file again, and apply, and we get the drawing. And with that, we have all the footprints built that I want to build for this particular board. So we're going to go ahead and close out Inkscape and switch back to KiCad. So back in KiCad, there's a number of different places that you can get to it. We want to go to the footprint editor to create footprints out of all the things that we've now fixed up and exported to KiCad format via Inkscape. So this little IC looking thing is the footprint editor. We can click on it. It will load up the other footprint libraries, which takes a moment. And here's the footprint editor. Now what we're going to want to do is simply, we're basically in a new footprint, or as you import them, it starts a new one anyway. So we're going to want to go ahead and import footprint from KiCad file, because that's what they are. In this case, we're in that same Point Doom graphics directory, and we can now grab, we'll grab our first one that we have, the Point Doom logo and writing and stuff. And as we'll see, this is in purple here now, which, as we can go check, means that this one happens to be the front mask. If we hide the visibility, we notice that it goes away. And then there's a couple other graphics that are on, not graphics, but other things that are associated with a footprint, a reference number, and a value. If it were a component, right, it would have a value. If it were a resistor, 100K, something like that. So what I do with these is I want to move these out of the way of this, just so that visually they're not in the way. And then also, by default, these are on the front silk screen, which would mean that if we put these down as footprints, they would, by default, show up in the drawing on there. And we don't want these on there at all. As we said, for other things, we use this drawings user layer. It's a hidden layer. It doesn't get seen by the manufacturing. And so we'll also go ahead, double click on these, and then change these to be on the drawings user. And say, OK. So now that we're ready to save it, before we do that, we need to create a new library. And we can, there's various libraries for the different types of footprints, and we're just going to make our own library and store it here in the point doom place, and we'll just give it a name. We'll also give it the name graphics, and this library will contain the 4 graphics that we've done. You get a choice of where you want to do this. You can say global if you want it available for all your projects. I don't know that I want these available on every project, so I'm just going to make it local to this project so that this particular library will only exist in this particular project at this time. And then it's created. So now that we have that created, we have a place to put this. When we go to save the actual graphics itself, we can filter on graphics to find our library. So we want that selected, and then the name will stick with point doom in there, and we hit save, and it's saved. If we go back to the footprint editor, we're ready to do the next footprint. So we can import another footprint from KiCad. We'll go ahead and, I guess we did the in one next, so we'll do that. Notice that this is turquoise. That represents the front silk screen, which is where we said we wanted this particular one. Again, we can change the visibility. You notice the visibility for the reference and the value also change. So again, select each of these individually, move them out of the way. I'm going to want to scroll out. Again, using the scroll wheel here works much the same as it does on the actual layout editor itself. And having problems grabbing the other one, get them off of top of each other. And again, we want to move this off the front silk screen. We don't want these to print on that layer. We'll put them onto the drawings user layer. And save the file. Again, we have to go find our graphics library, select it. We're going to stay with the name in, and we save it. Back to the footprint editor, import the next one. We'll go ahead and do out next. This one wanted to do, as I said, I wanted to make sure that I align things up with this plus sign that I put on the graphics. As you can see, everything's just sort of wherever on this. There's this blue crosshair here, which represents basically the center of the footprint, and that's where I'm going to want to put that crosshair. So let's go ahead and select everything here. Control A doesn't work, so we do grab the group. That selects everything. You can notice that everything got slightly lighter, and now we can move everything together as a group. We want to make sure move it together as a group, and then we can zoom in on the plus sign, and then we can kind of do what we can here to line it up exactly, that plus sign, like exactly with the center of those blue lines, like that. Zoom back out. Select outside. Again, we want to move the reference and the value pieces outside the shape itself, and move them off of the front silk screen onto drawings user. Save this. And one last one to do, the palm tree. So we'll import the new graphics. You can see what it looks like. This is going to be really tiny again. I know it's a little chunky looking and stuff, but on the board itself, it looks pretty cool because it's pretty easy to tell that it's the palm tree it's supposed to be. Again, it's purple, meaning that it is on the front mask. You can figure that out by turning it off and on again. Move the reference and the val text, and also put them onto the user drawing layer. and save it in our graphics library. Cool, so now that we have all of that, we're ready to place these footprints on the printed circuit board or on our panel itself. In the PCB new, in the PC layout tool, there's again the same little footprint icon. We can click on that, and that puts us into place a footprint mode. You can go, you just click to bring up on the drawing to bring up the dialog that has all the footprints available to them, all 11,887 of them that are available here. We can start searching for them though. We put them into the library called graphics. So if we type graphics in the search bar, you can see this, see the graphics, and you see the see specifically the graphics that we put in there. And we can even get a preview of what they're going to look like. Point Doom is the one we want. So if we say OK, it now has attached to our cursor the footprint that it wants to place, and then where we're going to place it. As I said, as you can see, it just fits inside of the board. I want to put it right here, just sort of where there's space for it on this particular board because it's so narrow and there's not a whole lot. There's going to be nuts around these each of these the holes where the jacks go and stuff. So even though it looks like, you know, they're fairly small, there's going to be a nut that goes almost out to the width of the board, and so if we placed it up here, it would be underneath the nut for that particular jack. So pretty much in the center, although I know that I'm going to place the in label on that jack right below it, well, right below the Point Doom, but above the jack is where I want it. So go ahead and click one more time, and then that will leave the Point Doom at that place there. So as I said, there's going to be nuts around each of these, the jacks that are here. I happen to know that those nuts are about 8 millimeters, and so it's probably going to be a good idea for these, the jacks where I'm going to put the in on them, to go ahead and draw where these nuts would go. So I'm going to go ahead and select Drawings User again after having turned it on. Go to the center of this particular circle, and then draw myself a circle representing the nut that has a radius of 4, right? Since I said that's 8 millimeters, and placing that there. And this will serve as our guide for how far up we want to put the in, and we'll do the same thing here. We won't actually get the absolute center of the circle as we try to draw it because that circle itself is on the edge cut layer, and the snaps sometimes only work on the same layers that they want. But that's okay because we're pretty close if I do that. So if I click on the circle and I go to create another one, and we just want to get a general idea. These are just guides and they aren't part of the final. They don't show up on the final board. They aren't part of the dimensions of anything. So just as drawing them as guides, we're going to go ahead and do that. So with that, I'm now ready to go back to the footprint view and select the in. We go ahead and filter again for our graphics library. We get our in. And as we can see, it's in the turquoise. It's light because it's the let me zoom out just a little bit. It's light because it's selected at the time. And we're going to go ahead and place it so that it's not covered up by the nut, and it's available there. We can, at this point, we can actually copy this one because we know that we need a second one. So if we right click on it, we can duplicate, which is actually Control D, also is another way to do it. And we get another one here available for us. And going down to our other input port, we can see that we have room to put that. So it's not covered up by the nut, but also just right under the Point Doom. At this point, I think I want to go ahead and nudge this Point Doom just a little bit to kind of set things off. We're going to have the same, we can go back to circle drawing. We're going to have the same nut on this one here, so we can go ahead and get the same representation. In this case, you see we get the target as we go to draw the circle, because there is an intersection on the user drawings layer. Draw this out to a radius of 4. And then with all that, we can see that, yeah, everything looks kind of nicely placed. The in should be up above the nut that's there. It's about the same height above it as, well, maybe it's a little bit different from where the one on the top is. But this is, you know, something you want to do is kind of click on it and drag and just move it up a little bit. What you want to do, though, is you want to make sure that everything sort of looks pleasant. And of course, when there's nuts on all the rest of these too, there's not going to be a whole lot of, even though it looks like there's a lot of room that you could stick things in between these, there really isn't once we have all the nuts in place. And so the only places to put things, I want to make sure that we have, you know, labels on the points of the board that we want labeled. And then maybe we can stick, you know, we'll be able to stick the palm trees in these little dead spaces next to the mounting screws. So yeah, with that, we'll go to the out next. And I don't know if I explained it, you know, particularly well, but on a lot of these modules and stuff, either all the inputs on the module will be highlighted in a certain way, or the outputs will be highlighted in a certain way. From what I've noticed, there's no real standard, but most of the modules that I've followed and emulated and such they tend to indicate which ports are outputs. And so we've designated the tops as the inputs for each of these, and then the 3 ports below them as the outputs. Electrically, they're all sort of the same, except for this particular input will have something special. We'll see when we lay out the board, it's switched, and if nothing's plugged into it, the outputs for it are actually connected to the same input on the top. But just for the sake of keeping it clear, now, you know, as you patch and everything, I'd recommend doing the same way, as, you know, use the standard and put your output you want replicated into the input of this module, and then take the outputs of this module and send them to the inputs of the other modules where you want your signal replicated. So the next thing we want to do is go back to foot placement and find our outputs, and it's in graphics and out. And we'll select that. So now in this case, again, I don't have all the guides and stuff, but I'm gonna use, you know, just sort of zoom in and then place this. As we can see, let's see, I don't want to zoom in too far because I want to see where it is left and right to make sure that it's lined up there. And then it's basically placed in the center of this particular jack. Go ahead and click to actually add it to the drawing. As you can see, you know, it stays outside of where that nut will be on the bottom. And so that's all looking pretty good. That's about where I want that to be. And then escape or click on the pointer mode to go back to pointer select. Let's select it again. If we hit Control D, it will duplicate it, and we have another one to place for the bottom. And we're going to do the same thing. Zoom in so we can see the placement left and right. We don't actually have guides here. We do happen to have that center guide still. That's okay though too, because we know we want it left and right. Get it about lined up and down with the center of the circle. And yeah, that looks pretty good. We'll turn off the user drawings again just so we can see what our whole board looks like. Go back to selection mode. And then this is what it's going to look like. Obviously, right, these will be the turquoise is white, the background's black, the things that are in purple are gold. So there's one last thing, is we made those palm trees that we want to stick on there just for sort of decoration. So we'll go back to the footprint selection and choose graphics to find our graphics library and our palm tree. And we have one, and it's just sort of the right size to go ahead and fit in there. Select it, Control D to duplicate it again, and we'll place one down here on the bottom also. And so that is pretty much it for what we want the front of our board to look like and how we want to send this off to be manufactured. So let's go ahead and save everything at this point. But there are a few other things, a couple other things that we have to do to ensure that things work out the way we want. At this point, there's no actual copper layer on the board itself. And so we want to go ahead and add a copper layer across that's the complete, covers the complete board. So that way, when the places where there aren't solder masks, like where things are showing in purple, the palm trees and the Point Doom, the solder mask won't be there, but we want the copper underneath so that the plating, the gold plating that will be there, is available too. And so to do that, we're going to go ahead to this particular tool, which is Add Filled Zones, and we're going to want to select Front Copper, and this draws a well, actually, because it thinks you're trying to lay out a board, it wants to know about what network it is. It doesn't matter because we're not laying out anything electrically. And so it draws basically a polygon. So we want to go and just find each of the corners of the board that's laid out. Just get it right out to the edge. This last corner here will complete the whole drawing, so double click there. And then as we can see, we get the footprint itself. Now, if you'll notice too, there's a little margin around the board. It has a clearance to the edge of where the footprint would be typically defined. So in the zone itself, we want to go in and select it. I guess right click and select its properties. And on here, you'll see here's this clearance, which is set to 0.508. We want to set it to 0. And if we say OK, it goes ahead and it sticks it all the way out to the edge. And as we can see, this is on the front copper layer. If we select it unselected, we're going to leave it unselected for now because it's hard to see things. So that then takes care of the front of the board. There's some stuff we want to do on the back. We want to also put copper on the back. I've submitted boards before. They're going to be done as two-sided boards because we need the silk screen on the back, as you'll see in a moment. And then we want to go ahead. So because it's two-sided, when they manufacture it, they expect to see some amount of copper on the back, and it's an error to them if it isn't. So we're going to go to our view, and we're going to flip the board view at the very bottom. And as you'll notice now, what it's done is it's flipped the whole drawing over. And so when the things that are on the front of our board, we see them as mirrored at this point because we're actually looking at the board from the back. We're going to go ahead and do another one of these regions on the back copper, and the operation is essentially the same. We'll start in the upper left-hand corner of the back. I guess we could have actually set the clearance to 0 here. We can see that it's still 0 when we start it. As you'll notice, it's preparing to color this in as green. On the back copper, they represent it with a green, a rather contrasted one. Select each of the corners. This is the third corner, but it defines the rest of the drawing, so we'll double click here to define the fill region. And that is all done for that. Again, turn it off just because it's like a little bit hard to see the graphics and stuff as it is. So the final thing we want to do here is in the manufacturing process, to be able to, when they separate, they build all these boards on a big panel, and then they go separate them, and so they end up with lots of little boards out of the panels, and they have to identify which boards belong to which purchaser. So your board will be made with a bunch of other folks' boards as they do them. So one of the things they do, and we'll see this when we go to submit the board to JLC PCB, is they offer you the option. So what they have to do is they have to print a number on the board so that they can identify as they pull them apart which pieces belong to which purchasers. And so we want to make sure, we don't want that showing up on the front, and if we don't tell them where we want it or pay an extra fee, they'll put it wherever they want to have it. So we're going to use the back silk screen. So we'll select that, and we're going to put text on there. And if you put special text, in the case for JLC PCB, it's JLC, the letters JLC repeated 4 times. So JLC, 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 JLC. And we get that text ready to place on the board. Now, it doesn't fit this way very well, and I think just for purposes of, I don't know, keeping things neat and tidy, we'll go ahead and rotate it and find a spot to put it. And this is probably just as good as any right along the line here. It's not inside the holes. They'll replace it with the number, with their identifying number that they need to do. They know that they need to do it. It's on the back. And unfortunately, the front mask is about the same color. We'll turn that off, but just to show that the point doom is still the front mask and this is the back silk. And then the other thing that's good to do on your boards is to go ahead and add just a little bit of information. So if you're going to run them a couple times or something like that. And so I like to give them a version number and a date when I built it. So that way, if I have them just lying around or something, I pick one up, I'll know a little bit about when I made it and where it was. So this one, we'll just call it version 1.0, and we can say December 2020 for when we made it. And then that too, let's go ahead and rotate. Let's also, I'm going to go ahead and place it here, but let's select it and let's make it just a little bit smaller. And so we'll make the height and the width. We'll make the width 0.75 for each letter. And the height too, to keep it all proportional. And that makes it just a little bit smaller. Again, we can turn the back silk layer off if we don't want to see it when we turn things over. Turn the front mask back on. Let's go ahead. Flip our board. Another look. It's always good to check and recheck and check again. But with that pretty much concludes everything we're going to do to the board. Thanks for watching, and I hope the information I shared here was useful. It will help keep me motivated to make more of these videos if I know people are watching them. You can help me out by leaving a comment or a like and sharing with friends who might also be interested. Also, please be sure to subscribe so you won't miss any future videos I make.